right, don't forget another word for zeros, roots. Also, which is what we're more familiar with, is solutions. So we're looking at solutions of your polynomial functions. Start off with our rational zero theorem. All right, so the possible rational zeros, we can find all possible rational zeros by doing plus or minus the factors of the constant over the factors of the leading coefficient. And where that comes from is this thought process. Let's say if I have 2x plus 3 equal to 0, and I want to solve for this. This is my constant. Your constant is the term that's not attached to any variable. And then this is my leading coefficient. Or the number that's in front of the variable, the highest exponent. So when I go to solve this, I will subtract 3 from both sides, then divide by 2. So notice the constant is on top, leading coefficient is on bottom. So now this theorem doesn't tell us, what our actual zeros are. It tells us our possible options, where we can start. Let's say if we were looking to solve a very long or very involved function, we can take the factors of our constant and the factors of our leading coefficient, set them up this way. At least we know our options and we can start plugging in values. And remember, our zeros or our solutions, when I plug them into the function, I will get 0. That's why they call zeros. So when I plug them into my equation, if I get a 0, then that lets me know that's one of my solutions. And we can go from there. So let's try this out. Let's go green. All right, so listen, all possible rational zeros of f of x equal to 15x cubed plus 14x squared minus 3x minus 2. So our constant is 2, and our leading coefficient is 15. All right, the factors of 2 are just 1 and 2. Factors of 15, 1 times 15, 3 times 5. Any problems so far? So our constant, once again, is the number that's sitting by itself, not attached to any variable. And then our leading coefficient is the number that's in front of the variable with the highest exponent. All right. So setting up our possible rational zeros, we can just do plus or minus. The plus or minus is attached to each term that we create. And so we're talking about the constant, the factors of your constant over the factors of your leading coefficient. So you just take this one, and place it over each one of these. So that's 1 over 1, 1 over 15, 1 over 3, 1 over 5. And then we'll do the same thing with 2. Take 2 and place it over each one of these. 2 over 1, 2 over 15, 2 over 3, and 2 over 5. All right, questions on what I've done? And like I said, that plus or minus goes in front of each, term. So it's plus or minus 1, plus or minus 1 over 15, plus or minus 1 over 3, and so on. And then, of course, you would simplify as much as possible. If you had any repeated values, then you wouldn't write the repeated values. In this case, we don't have any. But 1 over 1 is just 1. So those are all of your possible rational zeros. All right. Questions. All right. So we do that one more time just to make sure we are good. Want to list all possible zeros. Let's go 4x to the 5th. All right, so we have 4 and 6. Our constant is 6. Leading coefficient is 4. All right, so our constant is 6. That's 1 times 6, 2 times 3. And our 4 is 1 times 4. Now 4 is our leading coefficient, which the factors of 4 is 1 times 4 and 2 times 2. So I'll take each one of these and place it on top of or over each one of those. So possible rational zeros, that's 1 over 1, 1 over 4, 1 over 2. We don't have to write the 2 twice. And 6 over 1, 6 over 4, 6 over 2, 2 over 1, 2 over 4, 2 over 2, and 3 over 1, 3 over 4, 3 over 2. And we simplify as much as possible, write down distinct values. So 1 over 1 is just 1, 1 over 4, 1 over 2, that's 6. 6 over 4 reduces to 3 over 2. 6 over 2 is 3. 2 over 1 is 2. 2 over 4 is 1/2, so we don't need that one. 2 over 2 is 1, don't need that one. We already have it. 3 over 1 is 3, already have that one. 3/4, we need that. And then 3/2, we already have. So our actual list will be plus or minus each one of those numbers. Questions, questions, questions. So once again, with this list, it gives you a place to start. If you were to do a test in class, well, since we don't have any in class, but if we were doing a test in class, I would always give you at least one to start off with. But as far as homework, you may have one where it says find all the zeros, and what you would do is plug one in. So let's say if I have, let's see if they have a good one. All right, somebody in the chat. So these will not be on the test. Do we have to do? So yes, these will be on the test. I was just talking about if we were doing one in class. I was just thinking out loud, really. If we were doing it in class, I would always give you one. Now this part will always, this is no big deal. Possible rational zeros, yes. Now here where it says find all zeros, this is what I was talking about. Probably give you a short one like this, wherein and you'll see in a second. So if you have this list right here, you don't know which one of these will be a solution or which one will not be a solution. So what you have to do is just plug them in until you find one that is a solution. So if you were doing one in class, then of course that would be time consuming. So but since you guys are doing these at home and there's no timer, you should be okay with that. Because like I said, the ones I would give wouldn't have a whole lot of solutions. See here we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 16 possible solutions. So I wouldn't give you one like that. I would give you one like this one right here. It tells us to find all possible solutions. So first we recognize what our constant is. Our constant is 3. And our leading coefficient is 1. Factors of 3 is just 1 times 3. Factors of 1 is just 1 times 1. So the possible zeros, once again, we take all of these and place them on top of this. So it's 1 over 1, plus or minus 1 over 1, and then plus or minus 3 over 1. So those are the only ones, only options. We have 4 options here. 3.2. As of right now, no, we might go back to it. But we'll see when we get done with chapter 3. But right now, if we don't cover it, I can just leave for extra credit. Some people, ask for extra credit. So 3.2 can be extra credit, since I didn't discuss it as far as the lecture is concerned. So we have those 4 options. All right, no problem. All right, so we have those 4 options: +1, -1, +3, and -3. So we can plug those values in and see if we get 0. Remember, it's not a solution unless we get 0. And so we can use synthetic division. All right, so we'll use synthetic division to see which is a solution. And once again, our choices or options: +1, -1, +3, and -3. All right. We go black. So start off with 1 in the box. And our coefficients, 1, 7, 11. Oh, that should be an x right here. Sorry about that, guys. Right here should be 11x minus 3. Left the x off. Yeah. So our coefficients, 1, 7, 11, and -3. And in order for it to be a solution, we need a 0 right here. So follow synthetic division process. Bring your 1 down. 1 times 1 is 1. Add these together. 7 plus 1 is 8. 1 times 8 is 8. Take that up here. 11 plus 8 is 19. 1 times 19 is 19. -3 plus 19 is 16. So not a solution. Let me say it like this. All right, so it's not a solution because you need a 0 right there. Let's try -1. Follow the same process. Bring down 1. -1 times 1 is -1. 7 plus -1 is 6. -1 times 6 is -6. 11 plus -6 is 5. -1 times 5 is -5. So that gives us a -8. So once again, not a solution. And that's why I said that this process can be a little time consuming if you have like a whole bunch of solution options. But if you only have 4 options, it's not that big of a deal. Bring down 1. 3 times 1 is 3. Add them up, that's 10. 3 times 10 is 30. Add those together, that's 41. 3 times 41, that's 3, 120, 123. Add them together, that'd be 120. Once again, not a solution. So Got this last one, which is -3. And we hope that this is a solution. If it's not, that does not mean that there are no solutions. It just means that there are no rational solutions. Bring down 1. -3 times 1 is -3. Add them together, that's 4. -3 times 4 is -12. Add them together, that's -1. -3 times -1 is a +3. And that gives me 0. So -3 is going to be a solution for us. So now I can find the other two. Because remember, your degree of x, or degree of the polynomial, lets you know how many solutions we should receive. Our original function was x cubed plus 7x squared plus 11x minus 3. So we should get 3 solutions out of this. So we start off 1 degree less. We had x cubed, so now this is going to be x squared. 4x minus 1. You can check to see if that can factor, and it cannot. All right, so it cannot factor, so we will use the quadratic formula. All right, so let's go blue. All right, so we have to use our quadratic formula. X is equal to b plus or minus b squared minus 4ac all over 2a. So it's -4 plus or minus 4 squared minus 4 times 1 times -1. All over 2 times 1. 16 plus 4 over 2. It's 20. And don't forget to reduce this square root of 20. Take the square root of that, it's 4 times 5. Square root of 4 is 2. Leave the 5 under the radical. So that's a -4 plus or minus 2 square root of 5 over 2. That 2 can go into each term in the numerator. So that'd be -2 plus or minus square root of 5. And those would be your other 2 solutions. So you have 3 solutions. X equal to -3. X equal to -2 plus square root of 5. X equal to -2 minus square root of 5. All right, questions on what we did there? All right. All right, so the complex conjugate theorem. Okay, complex conjugate theorem. If a plus bi is a solution of f of x, then a minus bi is also a solution of the solution of f of x. All right, so just to make sure we're okay with what our conjugates are, when we have our complex numbers, you would just change the sign of the imaginary part, and that will be your complex conjugate. So 4 plus 5i and 4 minus 5i are conjugates of each other. Negative 2 plus 7i, negative 2 minus 7i. Notice the imaginary part is what changes. The real part stays the same. So the 2 stays negative, the 4 stays positive in both of those examples. And then if we just had negative 8i, then positive 8i would be the conjugate. And what the complex conjugate theorem states is that if one of those is the solution to f of x or is a solution to f of x, then the other one is a solution as well. So what will happen is that they will give you, or they could give you one with the assumption that you already know that the other one comes along with it. They will not give you both as a solution, but because you have one, you're supposed to know that the other one is a solution. All right, so we want to find a fourth degree polynomial function with real coefficients that has negative 2, 2, and I as zeros, and such that f of x is equal to, not f of x, sorry about that, should be f of 3. F of 3 is equal to negative 150. So when you see this type of problem we have going on here, they give the solutions and they want to know what function produce the solutions. So they give you the solutions and they want to know what function produced those solutions. So you're working in reverse. Normally you have the function and you want to find the solutions. This time they give you the solutions and they want you to find the function that gives those or produce those. All right. So the first piece of information that they give is that it's a fourth degree polynomial. That means we should get 4 solutions. All right. So we want a polynomial function with real coefficients. So we don't want any imaginary coefficients. Then they give us 3 solutions. And then this last part right here, f of 3, it says when I plug 3 into my function, I'm supposed to get out negative 150. That'll be the last thing that we address. So let's look at these first 2 pieces. We want 4 solutions. We only have 2, but remember what we just finished looking at, the complex conjugate theorem. When I look at my solutions, x is equal to negative 2, x is equal to positive 2, x is equal to I, and then also x is equal to negative I. Those are my 4 solutions. Once again, that negative I comes from the complex conjugate theorem. If I have an imaginary or complex number, then the conjugate will also be a solution. If I have a complex number as a solution, the conjugate will also be a solution. So now, don't forget how this or these solutions came to be. In order for me to get x equal to negative 2, I had to have x plus 2 equal to 0 first, right? If I subtract 2 from both sides, that's how I get negative 2 as a solution. So the way I'll set up my function creation is that I need to put an a here for a possible constant. We'll talk about that when we get to that last step. So we just put an a there for right now. That's going to be x minus negative 2, x minus 2, x minus I, and I ran out of room. Let me I'm write the same thing. I'm just going to put it closer together so I can write on the same line. All right, so that's what we're looking at. So you got x minus negative 2 times x minus 2 times x minus I times x minus negative I. So you want to set it up so we have our opposite signs. And you'll see that this x plus 2 will be generated right here. Negative to negative turns positive. All right, questions before we go any further? Everybody okay with what we did? All right. What I always suggest is that you multiply your imaginary parts or imaginary quantities to each other so that things can cancel, because remember, we want real coefficients. So we'll multiply x plus 2 times x minus 2 together as well. Just foiling. These two, same thing happens here. Just doing our distribution. So a is still there. We got x squared minus 2x plus 2x minus 4. X squared plus ix minus ix minus I squared. So 2i and negative 2i cancels in the first quantity. Ix and negative ix cancels in the second quantity. That'd be a times x squared minus 4. Then here we have x squared minus, don't forget I squared is not in its most simplest form. I squared is actually negative 1. So before we do any more distribution, what we have is a times x squared minus 4 times x squared plus 1. So before we distribute again, any questions on where we are? All right, so go ahead and distribute. Guess I'll stay with my green. All right, so it's going to be x to the 4th plus x squared minus 4x squared plus minus 4. Combine your like terms, x to the 4th minus 3x squared minus 4. So as of right now, this is our f of x. We're not done, but that's where we are so far. All right, so now we can consider that last initial condition. That was f of 3 is equal to negative 150. So when I plug 3 into my function, I'm supposed to get negative 150. So a is still out there. That's going to be 3 to the 4th minus 3 times 4 squared minus 4, and that's supposed to equal to, yeah, I'll put it over there, 150. And so if this quantity right here does not equal to 150, then we'll be able to solve for a and put in there what is going to make the function equal to 150. So 3 to the 4th is 81. I'll need that one over there. Oh, why do I have a 4 right here? Y'all let me put a 4 right here. It's supposed to be a 3. Plugging in 3 for x, and I put a 4 by mistake. So it should be a 9 right here, and then 3 times 9 is 27. Yep, gotta blame it on somebody, guys. So what's that? 27, that's 31. 81 minus 31 will be 50. So that's 58 equal to 150. And I left all this negative. So we got 58 equal to negative 150. We got a negative right here. So just make sure that negative is in your notes. Now divide by 50 in order to solve for A. A is equal to -3. All right, so before we finish off the function, questions. All right, so we can put a -3 into our function now for A. So that'd be -3 times x to the 4th. What is that? Minus 3x squared minus 4. That's what we should have had. Yep, 3x squared minus 4. Distribute that -3. So that's -3x to the 4th plus 9x squared plus 12. And that would be your function. Questions? All right, let's see what else is in this section. Let's do that one more time, make sure we're good. I think that's it as far as the type of problems in this section. Let's see what next we have. We got vertical asymptotes. 3, 5, 3, 6. Okay, we still got a little ways to go. Okay. All right, so let's do another one like that. Let's go third degree polynomial. And we have the solutions of -5 and 4 plus 3i. And let's go R, 2 rows. And f of 2 is equal to 91. So we have third degree polynomial that we're trying to get. -5, 4 plus 3i are zeros. And then f of 2 is equal to 91. So when I plug in 2, I'm supposed to get out 91. So we need 3 solutions, third degree polynomial. So we know x is equal to -5 is a solution. X equal to 4 plus 3i is a solution. And because 4 plus 3i is a solution, 4 minus 3i is also a solution. All right, questions? Set it up. That's going to be a times x minus I probably won't have enough room down there. So we always start off with a, x minus -5, x minus 4 plus 3i, and x minus 4 minus 3i. So notice the parentheses and how I have it set up. That minus sign needs to hit both terms. All right, so let's look at getting rid of these negatives on all these parentheses. So negative to negative turns positive here. Going to distribute it here and distribute it here. All right, so like I said last time, go ahead and multiply the quantities that have the imaginary terms in it first. Things should cancel out for us. We're going to do our distribution. This time we have 3 on 3 or 3 by 3. So we're going to take the x, multiply it to each term. Then we'll take the -4, do the same, take the -3i, and do the same. So a and x plus 5 will still be here. It's going to be x squared minus 4x plus 3xi minus 4x plus 16 minus 12i, and then minus 3xi plus 12i minus 9i squared. So always make sure whenever you have something like this, you got your terms right and your signs right. So always pays to go back and look. So x squared -4x plus 3xi -4x plus 16 minus 12i -3xi plus 12i minus 9i squared. Okay. Let's look to simplify and reduce. X squared cannot combine with anything. We have -4x and -4x. That'll be a -8x. Then we have positive 3xi, -3xi, plus 12i, -12i. We have a plus 16, and then imaginary, well, I squared, I should say. That'll be a -9 times -1. So that I squared is equal to -1. All right, -9 and -1 is a positive 9. So 16 plus 9 is 25. All right, so now we're going to take x and distribute it. Take 5 and do our distribution. A is still out there. That'll be x cubed minus 8x squared plus 25x. Then 5x squared minus 40x plus 125. Combine your like terms. So x cubed can't combine with anything. Negative 18x squared plus 5x squared. I said negative 18. Negative 8x squared plus 5x squared is negative 3x squared. Then 25x minus 40x is a negative 15x. That's a plus 125. Questions before we go to that last initial condition? All right, so now we need to figure out A. And that condition that they gave us was that when you plug in 2, you get out 91. Let me make sure. Yep. When you plug in 2, you get out 91. So plugging 2 into this function. So that'd be 2 cubed minus 3 times 2 squared minus 15 times 2 plus 125. And let me do this. Supposed to be equal to 91. So 2 cubed is 8. That's 2 times 2 times 2. 4 squared is 4. So that's 3 times 4. 15 times 2 is 30. So we have 125 in the back. 8 minus 12 minus 30 plus 125. 91. 8 minus 12 is negative 4. That's negative 34. And that is 91. 4, 34. Yep. So we have 91A equal to 91. So solving for A, we would just divide both sides by 91. That just means A is equal to 1. So there's nothing for us to distribute. We go to f of x. We'll plug it in. 1 for A. So that just means f of x is equal to x cubed minus 3x squared minus 15x plus 125. All right, questions on anything? All right. So this is where we can stop. Like I said, that was the last type of problem that they had in this section. Make sure you try this stuff out. Don't forget you have 2 tests that are sitting out there. Make sure you knock them out. You know, once you submit those tests, make sure you send me your scratch work as well. If you have any questions, shoot me that email and I'll answer it, or you can wait till the next class. Up to you how you want to do that, but just know that every class is an opportunity for questions. If you have any questions, feel free to ask. If not, that's it for today. I will see you on next class and be safe.
Mr. Tucker, I have a question about 3.2.
Mm-hmm.
Actually, I just